Hey, welcome back, everybody, to the latest episode of the Unbuild It podcast. Today's podcast is sponsored by Huber Engineered Woods. Yes, they are the makers of Advantech and Zip System solutions. Now, I could sit here and I could read all the metrics off of their website and tell you all the various products they have, sizes, R values, etc. But I'd rather tell you the things that you can't find on their website. I've been in the high performance home design business as an architect for close to 30 years. I've designed passive houses, zero energy houses, all along the spectrum of energy efficiency. And when it comes to looking for team players, I look for a company like Huber Engineered Woods. This is a company that, regardless of my technical question, my thoughts, my comments, they are always willing to listen. They are always willing to provide me with the best technical answer that they can provide. They are a true team player. And to be able to do what I do, I need to surround myself with manufacturers and companies just like Huber Engineered Woods. They've provided the development of products that continue to drive our industry, right? They came out with the original Zip system, and then they went one step above and they laminated rigid insulation to it, and now we have the Zip R system. So they just continue to push forward with innovative decisions and designs in their products. And I can only look forward to the next thing that they deliver. So I encourage you to look to Huber Engineered Woods for your sheathing solutions. Also sponsoring today's podcast is Siga. Siga is a leader in the development and production of high-performance products, specifically the Myrex 200. Now, the Myrex 200 is a single-directional vapor transport vapor retarder. I'm currently doing a project where the Siga Myrex is actually an exceptional solution for my problems. Now, what, may you ask, is a single direction vapor transport? Well, it's a vapor retarder that is permeable from 0.16 to 1.3 perms towards the insulation, but should the wall assembly get wet, the permeance to dry out that wall assembly, the Myrex on the reverse side increases from 0.17 to 3.8 perms. So if you're looking for that airtight barrier to put on the inside of your insulation walls and provide exceptional vapor control, look no further than Siga's Myrex 200. So onward to the podcast. Hope you enjoy it. This one's a treat. Thanks for listening. Hey everybody, welcome back to the Unbuild It podcast. We got a real treat for you today. It's actually like a bonus. We not only do we get a guest speaker and a great guest speaker, but we don't have Jake. So that's a win-win. So I know he's listening, and you know I sent him some Kleenex, so let's not worry about Jake. He'll be fine.
Well, and he's our adult supervision, Steve. So we're really winging it.
I know, but that allows me to roll today, Peter. I can roll today.
It's playtime.
Great. It's playtime. So who do we have today? Today we have my good friend Ken Kiefer. I've known Ken for a long time. Ken works for Siga Products, and Siga is the Swiss company. They're the maker of a lot of membranes, tapes, and vapor barriers. And we're in for a real treat today because I actually have a project where we're going to rely on one of their products very heavily. So this is kind of a great opportunity for me to lay out that project, let Peter scrutinize it, but then also have Ken here to help us out talking about that product. So,
and Ken and I don't know each other. So Ken, great to meet you. Thanks for coming on Unbuild It podcast.
Absolutely. Thank you for having me. It's a pleasure to be here.
And Ken, do you want to tell us a little bit about yourself, where you're at, what you do, all that good stuff?
Yeah, so I've been working for Siga now for about 5 years. It's been a fantastic 5-year journey. Um, I live myself in New Hampshire. We actually have a training center here in New Hampshire as well. So I live, work, and play in New Hampshire, but of course I go all over New England to support projects and to help people out, make sure their buildings are tight and dry, because those are pretty important things, I suppose. Um, but yeah, I mean, I'm just one of those the good old boys from the Motor City that didn't end up in the car business. I ended up in the building business, and it's been pretty fantastic.
Yeah, and one thing I could say about Ken is it's a treat to work with them. I use a lot of their tapes for window installations, and the beauty is I can email Ken a window schedule, and 2 days later a box of window flashing tape just shows up at the job site, ready for the builder. So it's really great. You've heard me speak before on it, but it's really great when you get to work with partners that have their act together, and you don't have to do the extra steps that they take care of, and you don't have to worry about it. I fire it off to Ken. I don't worry about it. I just know it's going to be there in a couple days. So.
And we were just talking about how with Steve in Massachusetts, me in Vermont, and Ken in New Hampshire, I had a project that I went to on Monday where the builder used the Siga package for all the windows and doors. And I think we're going to we were at 465 CFM 50, but it's a big, complicated house. I think we're going to be in the 0.4 ACH 50 range.
Beautiful.
Yeah, and the tapes really, he did a great job installing the builder. And I think that this is one of the first projects he's done where airtightness was a super focus. So he was pretty nervous, but man, he nailed it.
It's nice because really cool. They get nervous the first time, but once they nail it, then that right there is just the icing on the cake for them. They want to keep doing it after that. Like, oh, this isn't so bad.
Yeah.
Well, and Peter, just so you know, Siga's vision, and I quote them, is a world with zero energy loss buildings. So that's their goal, is to seal it up,
taking over the world,
tighten it up. And you know how I feel about taking control. I love it. It's I want to be a dictator with my buildings. So
here's a little shameless plug. We have we just added on to our second factory in Schachen, Switzerland, and we added rooftop solar, facade solar, and then built the envelope really nice and tight and well insulated. And now that factory produces 120% of its own energy usage.
For a factory.
So,
wow.
For a factory. So, we're net positive on that. So we like to put our money where our mouth is.
So you don't have any ground mount. This is strictly building PV that's meeting the factory load?
Right.
That is awesome.
Yeah, it's cool.
I always thought about, like, you have all these, and I'm not going to place any names, but we know who they are. These big box companies that build these massive boxes all over the country, and why, like, zoning and all of this say, hey, yeah, you can come in, you can put your big box store here, but we want 75% of it to be site generated power.
Yeah, interesting.
Right?
Yeah.
Or whatever. It's like, if you're going to come in here and kind of take over, then we should get something out of it.
So this is
it shouldn't be a burden.
This is part of your take control. You're going to mandate PV now, Steve?
Well, yeah. It was
I don't know. I'm
I don't
really
want to.
surprised.
What's another word for dictatorship? Because I can't use that. God, people will crucify me if I continue to use that word. But what's another word?
Authoritarian.
Authoritarian. Yeah, it's
sort of
like
a gentler, kinder, more kind.
How about I just
dictator?
want to be bossy? How's that? There we go. Some nice street slang.
You should stick with bossy. Yeah.
I want to be bossy about it. There we go. I like it. Bossy. All right.
Hey, I got a quick question for Ken, Steve.
Go ahead, buddy.
Just because he mentioned the training center, tell me about that. I didn't know there was a training center, and it's in New England.
Yes, yeah. So we opened this up in October, and It's a roughly 1,200 square foot facility. We've got two 7-foot cube boxes that we had Benson Wood put together for us.
Huh.
So we've got window openings in there. We've got different connections that we can do, and we just basically bring whoever wants to come in. Currently, our setup is a 4-hour interactive course. So we do an hour of maybe about 45 minutes of building science theory, and then we take them over to the mock-ups, and they get to work with what we just talked about and put it into physical practice on the mock-ups. Currently, we've kind of been on a hiatus because of what we're all going through.
Oh yeah, yeah.
But during that hiatus, we're actually taking some time to add on to our offerings, looking at ways we can put in full day courses. We're looking at doing some hybrid options where I've been playing around with some cardboard boxes that we can put together and make mock-ups out of. That way I can send them out to people and they can jump on a virtual class and actually still get that physical hands-on experience that everyone loves so much about what we do. But it's currently our 4-hour classes are free.
Wow, that's cool.
We're looking to bolster all those different types of things. But yeah, that's one of the covenants of our company is education. We have one training center in Rooseville, Switzerland, at our headquarters. We've got one in Oslo, Norway. We've got the one here in New Hampshire, and then we have also got one that will be opening soon on the west coast of Canada.
I'd love to go to the Oslo, Norway one.
We'll have to go together.
Because there you go. How are they? So talk to me about how well are those facilities received over there as opposed to America?
There are waiting lists for those facilities in Europe. That's one of I think the great things about the European kind of culture of building is that they're always looking to learn better ways to do things. And I'm starting to see that a lot more around here. It's not just old hat. Hey, Joe told me how to do this once 20 years ago, and I'm going to stick with that for the rest of my life. I'm starting to see a lot more builders that are more like, hey, what's new? How can I do better?
So here's my bossy coming out, Peter. So you with these classes, it's very interesting to me because I get all the time. I know, Peter, you do too. I get messages. I could show you my phone. It just rattles with, hey, Steve, where can I find really good information? Where can I get trusted information and all of this? And then you tell people, oh, well, there's a training center here, or hey, you can go to this training. Oh, well, I can't take that afternoon off. I'm too busy. And my pet peeve is you're exactly the guy or gal that should go to that. Because if you can't take 3 or 4 hours out of a month to go get training to enhance what you do, then you're not doing what you're supposed to be doing, in my eyes. You're not managing your company well if you can't walk away for 3 hours, and you're not being, you're not instilling the right discipline to gain knowledge if you're not doing that. So I think it's important. I mean, we're all busy. I'm busy too, but I find time, and I still go out to little regional conferences and stuff to see people talk about it, see what new products are, and to meet people like you, Ken, and to stand there for 15 minutes and say, hey, what can I expect in the next year or two from you? Get that little wiki leak on what's coming down the pipe, or what you guys are thinking about, or vice versa. I know you guys like to hear it too. It's like, hey, I would love to have a product that can stick to this, do that, and be vapor permeable. Why don't you guys go back to Switzerland, figure it out, and come back with something? Right. So it's a give and take world, but so many people, oh, I don't know where to go for this information, and then you tell them, and it's, oh, I can't take the time. It's you know what? Figure it out.
Yeah, here's the thing though, is like if you take the currently 4 hours to come up and understand these products and their usage better, you're going to make that time up tenfold.
Sure, yeah.
Yeah, the first house you do, installing 30 windows and flashing them.
Right.
That 4 hours is worth the tips and tricks.
Exactly.
And all you have to do is have one window fail, just one.
And there's your
and
4
that
hours.
4 hours is exponentially wasted, right? You'll waste 12 hours chasing that stupid leak.
Absolutely.
So, yeah, it's okay, America. That's my bossy America today. Is let's get Ken a waiting list. That's our goal for 2021. Is let's get Ken a waiting list up there. But all right, so you guys did a very fine job of derailing me. Even though Jake isn't here, you guys still have a way to get me to get sidetracked here. But one of the products that I think is very intriguing is your Myrex product. And the reason it's intriguing is you got me right from the start, man, because it's not a vapor barrier. It is not a vapor retarder. It is a single direction vapor transport retarder.
Right.
Which, I think I need a PhD to just disseminate the title. But anyways, talk to me a little bit about that, Ken. What are we doing there? Single direction vapor transport.
So think of
sounds Star Trekky.
Like a check. How about this? It's like a check valve for vapor.
Vapor.
It's less permeable. So from the inside of the house or building or whatever it is that you're doing into the wall cavity is from like 0.16 perms to like 1.3 at 100% relative humidity. So we're keeping vapor out of the wall assembly. But
so it's a highly limiting barrier as far as moving moisture into an assembly.
Right, exactly. But
Gotcha.
For those times, I mean, we're all in New England. We know that on a hot, humid day, like we had so many of this year, there is an opportunity for vapor to turn around and drive the other way. So we don't want to then stop the vapor at the wall assembly, in the insulation layer. So we want to allow that to kind of move through in the other direction. So from the outside to the inside, we want to allow it to move through the wall assembly into the interior where your mechanicals can kind of manage that vapor on the inside. And so that gives us, we have a perm rating from out to in of 0.17 to 3.8.
Very interesting. So the lower limits, they stay relatively about the same, but the upper limit more than doubles. Right. In coming back the other way. So it's kind of a saving grace retarder.
Right. And it's super safe. So the idea was like, think about like even commercial buildings. Code says, commercial buildings, they have a rubber roof. Code says you also have to have a vapor retarder. Well, now you have a vapor sandwich.
Mm-hmm.
So that was the original design intent.
Code doesn't always know best.
Code doesn't. So we have that was our design intent, and through years of testing with the University of Dresden, we found that 99.99% of wall systems, this is like the safest vapor control layer you can put in a building, because it prevents vapor from getting in there but doesn't trap it. So it still acts like that vapor barrier that we all know and love, but then it acts like a smart vapor control layer in the other way. Whereas other smart vapor control layers, there's a ton of them on the market. Once they get to those upper limits of relative humidity, let's say new construction, you're at 85-90% relative humidity. They get up over 10 perms, and you're flooding the wall cavity with maybe more vapor than it can handle. So that's another thing. It's like, especially in the cold climates when we're building new buildings, we don't have to dehumidify the space while you're doing this.
So Ken, your relief valve from inside the cavity to the inside of the building is at 3.8 perms. So it's going from a class 2 retarder to a class 3 retarder in terms of the
correct.
How the code categorizes it. And do you have climate limitations? Like, when we think of smart vapor retarders, other smart vapor retarders that are not unidirectional, I think that there were or are limits down to climate zone 5-ish. Does the Myrex have recommendations or requirements for what climates can and can't be used in?
I know we've tested it down to we've tested some projects down in like the DC, Virginia area.
So,
So
climate zone 4.
right,
Yeah.
and we're good down there. I don't know as far as like if you start getting into like the southeast where it's stupid hot and humid all the time. I don't know about that, but that is definitely a question I can get an answer to real fast.
And is it? Can you double Myrex as your vapor control layer and your interior air control layer as well?
Absolutely,
Right?
as long as it's tape sealed and continuous.
Yeah.
Yeah,
Um,
it's perfect for that.
So it's 100% air impermeable.
Right.
All right. So I'm just going to touch on that because I feel bossy today. I got that in my head. But I know the Europeans, they love interior air barriers.
Love them.
I am at a loss for the love of an interior air barrier. So I'll just leave it at that.
That's all right,
But
Steve. I'm on your side.
It just any what and I'd like to say I was taught by the best. And the simple rules were every time I bend, twist, or turn, I complicate things. Mm-hmm. So if I can leave things in a straight line on the outside of the building, then it makes sense to me.
Right.
And I've gone round and round. So I even forget who it was, but I know it was probably like 7 or 8 years ago. I picked a fight at a conference with a Siga guy. That's no surprise. And it was basically just talking about how I just don't understand the interior. And part of me believes that it works in Europe because they have masonry buildings, so they're forced to come inside with it, although they could potentially use a lot of their stucco exteriors. But on the masonry, they're forced to bring it inside. But then we just translate that information to America, but we don't acknowledge that our building assemblies are slightly different. So we're trying to, it appears to me anyway, that we're trying to adhere a methodology that was born of a different building assembly and then trying to just bring it over here and attach it to a different building assembly without really thinking it through. But that is totally my personal opinion.
Well, I kind of share that, Steve. I mean, if you think about, then I know I'm probably going to get a phone call from the Swiss after this, but if you think about just how little or how unlikely the exterior of the building's air barrier is to damage over time, right? You don't typically touch that for a long time. Right. But the interior, my wife and I are constantly fiddling with things in here. Oh, I want to move the sink over here. Oh, I want to hang the TV there. I want to put a picture here.
We're going to remodel the bathroom and put a medicine cabinet here or recess it.
Right. As soon as you start doing all that,
Oh, what's this paper? We'll just cut it out.
But I will say though, I don't find a problem with putting 2 air barriers in there.
Yeah, I was going to say, and I know Peter always loves the belt and suspenders approach, but that's what I would typically do is that I would generate what I would consider my primary air barrier on the outside of the building. And then I would still, I would put the Myrex in and I would tape it and treat it continuously and seal it all up and call it a secondary air barrier and just create that most torturous path for that airstream as possible.
Yeah.
And I do think there's a difference if you have really deep cavities in either roofs or walls and you fill them with an air permeable insulation. Now you've got my attention for both a continuous exterior air control layer and a continuous interior control layer. So I think there are, special assemblies, and we're talking about a lot of high performance assemblies where we are looking to fill the cavity with a low embodied energy, and a lot of times that's going to be an air permeable insulation. All right, now I understand why we would be attracted to 2 air control layers rather than just 1.
All right, so let me put some specs to that thought for a second, Peter, because I want to make sure I understand it. And so if I did a 12-inch double wall filled with cellulose, plywood on the outside with whatever siding, and I or put zip on the outside and seal it up. That's my primary air barrier. On the inside, you're saying putting a Myrex product enhances that system in your eyes as opposed to just putting drywall on the inside of that wall.
Yeah, I mean, I'm not completely convinced that we can get really significant addition of vapor into a deep air permeable cavity without the driving force, right? The driving force for air leakage is 2 holes in a pathway. Right. And so, you know, if you have a continuous air control air on the outside, and that deep cavity has air permeability but no pathway, you know, you can get moisture that's looping in there, but I think that's a relatively small amount of moisture. However, if I'm going to spend all the time and effort to do a deep cavity and put air permeable insulation in it, I'm gonna want the belt and suspenders of a double control air for air.
Well, in only the way that I knew you would do it is you built a defense before I was able to ask the question. Because I was going to say, okay, now take that double wall assembly with my primary air barrier on the outside and attach a 0.4 air leakage number to it. Are you still worried about, you know, moisture getting in that cavity? Because the only way to drive it in there is diffusion. We can't bring it in, you know, via air transport because there is no air moving across that. So, but you like I said, you're always a step ahead of me, and that's fine. That's fine.
It's scary that we're on the same wavelength, Steve. That really worries the hell out of me.
Well, it excites me actually. So, but makes me feel good. Thank you.
So Ken, we talked about this just a little bit, but so we have a smart vapor retarder which has a variable vapor permeability, and I was thinking, well, wait a minute. The only way that you could get a directional control of vapor would be maybe like hysteresis, right? That that's when you get a difference in the way something behaves when it's wetting as compared to when it's drying. But that's not what's happening here. You actually can build polymers that have sort of differentiation of pores across the thickness of the material. Is that correct?
Yeah, I mean that's a good way to just kind of make it simple, because they've gone through and explained this to us, and I'm just like, you guys are a lot smarter than I am. So I mean, good for you.
No,
you know, they try to liken it to like a cactus skin. You know, it transports water in from the outside, and then it kind of lives on the inside, doesn't let it back out. That was their way of trying to simplify it, but yeah, it's more of a complex chemistry than something simple like that. But at least we have a way to kind of break that down a little more simple.
Yeah.
And Ken, you know, I tell people it's like on podcast day, I have to wake up early. I have to do like my brain teasers, my Sudoku. I got to drink my fish oil because I know I'm spending the next hour with Peter, and I have to have my mind right.
Exactly.
You know,
got to get your mind right. Yeah, got to get your mind right.
I got to get up and like get my mind exercised properly, so I'm like ready for that sprint now.
Do a little mental gymnastics.
Yeah, exactly. You can't come on this podcast with Peter, you know, just rolling out of bed. You'll get killed.
Yeah, but that's only because by 9:00, as you said, I'm halfway through my day.
Yeah, you're halfway through your day.
If we schedule a podcast for like 8 p.m., I'm going to be in real trouble.
Yeah, you're exactly. So while we're talking about this, I have a project with Jake, and we actually searched out using Myrex to solve a problem that not a problem, but a set of parameters.
Yeah.
And it appeared, you know, we went to ATN and Ken, of course, and said, hey, here's what we have. And they agreed that Myrex being a really great solution for that. So let me lay it out here for you, Peter, because I know you're going to love this because it has everything that you love in it.
I can't
Vapor, building science, roof assembly, ventilation.
Cool.
It is all in there. So we have this roof on a project. It is over a giant living room, great room. That's about, well, it is 18 feet by 42 feet long.
Mm-hmm.
It's a shed roof that goes the long axis. Its slope is 1.5 in 12, and we're putting a metal roof on it. And it is vented. And I know right away you say, wow, that is a bossy move, venting a 1.5 in 12 roof. So in doing that, our venting goes, it's at the base. We have a 10-foot soffit at the base to allow air into it. And we're building it as a double roof assembly. So we have our trusses will get sheathed. Then we're putting 2x4 sleepers with a second roof plane on it. So we have this full 1.5-inch vented chute on the outside of the primary roof sheathing. And that's, like I said, connected to a 10-foot ventilated soffit at the bottom. On the two sides, there are 18-inch or 24-inch rakes that are totally vented all the way up the side, and then it's vented at the top. Now, one of our primary concerns was we were going to do this with a blown, air-permeable cellulose insulation in there and vent it. But because of the slight slope, we said, how do we mitigate the least amount of moisture? Now, we feel good about our ventilation system, but it's kind of like a rain screen, right? I feel better about it if I can get rid of most of the problem immediately, or not have most of the problem be introduced to the assembly. So our thought was, what do we put at the ceiling that highly limits our ability to allow air or vapor to move into that assembly, so we can keep that moisture content up there at the lowest we possibly can. So we only have to deal with the lowest amount of moisture that will get in there. So here you go. Myrex to the rescue. We're going to use that as, the air barrier across the ceiling, but also as this single direction vapor transport retarder. So what do you think about that, my friend Peter?
Well, so just want to make sure I understand. You've got, how deep is the cavity that you're going to fill with air permeable insulation?
It varies. On the low side, it starts out with a 12-inch heel height, but it will go up to about 26 inches of cellulose.
Got it.
So it's roughly like an R70-ish
averaged out
assembly. Yeah, averaged out.
Well, so you're not going to be surprised to hear me say that the most important thing is to get that air barrier or the air control area continuous across the roof. And I think, and Ken can help me out here, but the difference between using, say, a standard smart vapor retarder is that they go from, class 2, but they're vapor open once they get wet, to above 10. That's correct, Ken?
Correct, yeah. Some of them get up 13, 14 perms at
13, 14.
I thought it was even, doesn't like membrane climb into the 20s?
Yeah, but membrane is not class 2 on the low end. I think it's more on the, so
I think it starts at like 10 or 11 or something.
No, I mean, it does qualify per the code. I think it's right around 1 perm.
Oh, okay. Yeah.
Which is the border between class 2 and class 3. But as I understand it, Ken, the problem with that approach is that when it gets wet, it becomes too vapor open.
Right. It has the opportunity to be, yeah.
Has the opportunity to be. So you're going to have, if that membrane gets high in moisture content, it's only going to open up by design from the inside of the cavity to dry to the interior up to a class 3 retarder. So it sort of maintains its ability to restrict inward moisture flow, even though it is relatively open for vapor moving out of the assembly at 3.8 perms.
Right. Yeah. So the Myrex, it's going to restrict it. It's going to stay very restrictive from the inside out.
Yes.
So that way, that just what you said is, if we have too much moisture, if it opens too far, we're going to overload the assembly with more moisture than it can handle. There's an opportunity to overload that assembly depending on all the variables within the building. But
so Steve, to me, the attraction for the difference between a quote unquote standard smart vapor retarder and Myrex is, what if you have high interior humidity during the winter in an assembly, right? That's a situation where if you can't pull that wintertime interior relative humidity down, then you do want some sort of smart retarder that's going to say, hey, you've got high interior conditions here. We're going to allow some drying from the interior of the cavity to the inside of the building, but we're not going to let high humidity inside the building into that cavity.
Right.
And so you could say, well, why can't you just, do what Joe Stiebrick does, which is say, hey, keep your wintertime relative humidity at 25%. Well, there's a whole bunch of people out there that, that don't want to have the winter conditions like that. So this allows you to move up to a much higher interior relative humidity in the winter.
Yeah, and just to expand the parameters of this project, it is climate zone 4, and it has whole house ventilation and air purification, I believe, even.
Yeah. Hey, Ken, I'm curious. When I've come up against a wall with, I typically tell people, you want to make sure that your interior wintertime relative humidity is 40% or lower. I have had 2 situations where people's doctors have said, you must keep the relative humidity above 40%, between 40 and 50%, for medical reasons. Dry eye syndrome, people with asthma, that when the air gets too dry, that can irritate people that are sensitive to that lower moisture content. Have you heard the same thing?
Yeah, I mean, so like I have an example of, my son has pretty severe allergies, and the doctor constantly recommends, hey, put a humidifier in his room, and it's a small little 10 by 10 room, so it gets really humid in there in the wintertime, like condensation on the windows and stuff like that. So the rest of the house, I live in a 1970s split level, so it's super air leaky, which means it's not humid at all in this house ever. I think our relative humidity, according to my Nest thermostat, is around 19% in the wintertime. But his room is not. His room is much higher than that. Well, he's sleeping. But yeah, I mean, and I've also been to like assisted living facilities where they have humidifiers in their rooms for the elderly. They're a little bit more sensitive to humidity concerns than us younger guys. So there's a lot of options.
Peter, one of these times when you're up here and we have some time, I'll take you out to this one project. It's an interior pool for an older gentleman that uses it for therapy. The conditions by which he considers comfortable, it would make someone living on the equator uncomfortable.
Yeah.
It is, I mean, we're talking like this pool house is probably on the order of 80 degrees in temperature, and the RH has got to be close to 70+% in there. Like I walk in there, I can spend about 30 seconds, and it's like I can't even breathe anymore. Yeah. And he's like, "Oh, I love this. It makes me feel so good."
Yeah, you're swimming before you even get in the pool.
Yeah, pretty much. It's like, oh my God, leave the door open when you go in, just because.
Yeah.
But the building was designed properly, and it's functioning extremely well, even at those elevated conditions. So
yeah, there's no doubt that you can find plenty of spaces that have interior moisture conditions in the winter that are being driven by different senses of thermal comfort, and certainly natatoriums, indoor swimming pools are big. I mean, the recommendations for what your temperature and relative humidity should be are pretty near the upper half, or certainly in the upper half of the psychrometric chart.
Yeah, and if you think too, just new construction, you're pouring a swimming pool in the house when you pour your foundation, your tile work, your mortars and thin sets and all these things go into just loading these buildings with moisture for the first year to 3 years, depending on how you dehumidify the space or not.
Listen, I have the best anecdotal story for that. So I was doing some consulting work with a big time builder in the Boston area years ago, and he was working on a project. Now, keep these stats in mind. The foundation was almost 300 feet long. It ranged from about 28 to 40 feet in width.
Mm.
The foundation wall was 16 inches thick, 16 feet tall. And the slab was a double slab assembly where we poured a slab, waterproofed it, and then poured the actual slab above it. But anyways, one of the things I told the builder, and he had all the walls, they were precast concrete. So they were going to come, and it was a trussed roof. He's like, I'll have this place closed in like 3 months, 4 months, which I was amazed at. And I said, well, my concern would be exactly what you just talked about, Ken. Think about that foundation. It's a dry dock,
Yep.
Right? And I have pictures of it, and it's exactly what it looks like. And so we were talking with the architect, and the builder had mentioned it to the architect and said, hey, we have some concerns. How do you want to deal with the moisture problem? And he said, well, what moisture problem? And the builder and I looked at each other like, is he messing with us, or does he not get it? And he's like, well, what moisture problem are you guys worried about? It's like, well, why don't you think about the literal thousands of gallons of water in that foundation system, right? 300 feet long, 16 feet tall, 16-inch thick walls. All that water has got to come out someday, right? And if you close the building in 3 months, it's going to be coming out while you're doing it. So the builder just went out on his own and got 2 literal, like almost half a tractor trailer commercial sized dehumidifiers and placed them in the basement in this building and just ran them for like 6 months.
Yeah, it's a one-time load, but it can be a really, really serious one if you mess with it.
Yeah, I mean, I had a project that we were working on. We just did all the exterior stuff, so they didn't use our interior vapor control. They used a standard smart membrane. This was in Greenfield, Massachusetts, and it's new construction. It was like October, November, where they were doing this. And I get a phone call from the architect asking me to come in and help them figure out what's going on with the roof. And then he sends me an email, and you can see the shingles on the roof were buckled at every joint of the plywood sheathing at the roof. And it's a vented roof assembly. And they're like, what is going on? So we're there, the roofing company's there, the insulation company's there that did all this. And through the pictures, I noticed a smart membrane that was installed. They said, all right, well, this is a wintertime build. Did you dehumidify during the build process? And he was like, well, no, why should I? So I pulled up the technical data on the smart membrane, and right in the technical data, the literature that comes with it says must be dehumidified during wintertime builds. And there was the problem. It was just overloading the system. So the system was designed to handle vapor transport, but it was overloading the system with more vapor than it could handle. And so the solution to that was just to wait it out, dehumidify and wait it out. And, that was hard for the building owner to kind of accept, but that was the recommendation from the roofing company, the roofing manufacturer, the insulation manufacturer. And, thankfully, once they did realize that it was a interior humidity problem causing that, and they took the steps to fix it, like from a ventilation and dehumidification standpoint, everything did settle back down and everyone was happy. But, those are things that you definitely have to worry about and think about.
Yeah, I actually had a project where the builder broke ground and moved the people in 11 weeks.
Whoa.
Yeah, and that moisture of construction really came back to tag him.
Sure.
I think I calculated for that project. In the first 6 months, it was about 17,000 pounds of water that were the one-time construction load coming into
Wow.
that building. There are eight pints, per gallon, but that's an awful lot of moisture to
absolutely.
be dealing with. Hey, so Steve, we spent some time on Myrex. Are we going to talk about tapes at all, too?
I mean, they have a whole family of products. I just use their MyVest 500 SA product,
Mm-hmm.
which it's a self-adhered weather-resistant barrier that's vapor permeable. And the reason we used it there, Peter, is I was working on you'll like this too. I was working on a coastal project with a builder. It's a very good house. Very good meaning the size and cost. And to limit their or to enhance the wall assembly, the builder chose to move to using Advantech as the wall sheathing.
Mm-hmm. Yeah, I remember you telling me about this project.
And so we ended up sheathing the whole building in 1/2-inch Advantech. They actually make 1/2-inch structural sheathing in the same way they make the Advantech floors. And so you can imagine, I have 100% trust in their floors. I can't imagine that their wall, putting it on the wall is going to perform any differently. But when you do that, we don't have the adhered or integrated weather-resistant barrier like you do on Zip.
Right.
So we had to search for something. So again, I called my good friends Ken and ATN at Siga and said, "Hey guys, here's what we got. What do we do?" And they said, MyVest 500 SA, and the builder loved it. It went on beautifully. I mean, it's a self-adhered membrane. What's the length on the roll, Ken, or the width?
It's 5 foot tall by 100 foot long.
Yeah, so it was easily managed, rolled out. We had to roll it and kind of squeegee it on, but
yeah, it is a pressure-sensitive adhesive.
If you want to talk a little bit about it, Ken, go ahead.
Yeah, we developed that as a unique product for the U.S. market because they don't typically build with things like that in Europe. So this is one of the U.S. developed materials that we actually have. Europe, the Europeans actually fell in love with it and are starting to use it now, especially in the prefab industry, which was kind of cool about your project, Steve, because it was like prefab, but on site.
Yeah, one of the things about that, Peter, is the same property, we built this massive barn, and while the builder was messing around with the foundation, which the drilling, blasting, excavation, and foundation prep was literally about 4 months worth of work. And so what he did was he had all his carpenters in the barn, and they built like 350 linear feet of exterior wall.
Oh.
So they framed all the walls on the flat. So this MyVest, they were able to install it as carpeting, if you will. Right. It was installed on the flat, and then, adhering it and rolling it, they just had a regular roller where, that you would use for like linoleum and that kind of thing.
It's almost factory applied.
Yeah. So we built our own little factory there, and they had all these walls and numbered, and then once the foundation and framing started, they just carried them, up the driveway with the lull.
Yeah.
And installed it. But it was real good quality control. And I will say, I'm gonna plug Ken here. A couple things. One, hearing him speak today, this is a rep that understands his products, knows what he's talking about. He understands building science. He can have a legitimate conversation with you. And two, Ken's the kind of guy that, he's going to stop in once a week and just check. Do you guys have the right materials? Do you need any more squeegee tools? Do you need, what do you guys need? And hey, let me take a look at this. Hey guys, let's pay a little bit more of attention to this or that. And he's what you want to work with. So,
well, I think that just goes to not just myself, but what the company looks for when they're bringing people on is it's important to the company. It's a privately owned business, so we don't have anybody to make happy but the people who work for the company. So we take that approach as like, there's a lot of great materials available for building, but a lot of these companies don't offer that level of support that Siga wants to offer. I mean, if you're going to trust us with your building, we're going to go out and make sure that you're successful.
yeah.
We're going to bend over backwards to make that happen.
And what do we always say, Peter? Right? There's a lot of good materials out there. What's the best one is the one that's installed right.
Yeah,
right.
So
absolutely.
when you have someone like Ken coming out and ensuring that installation is right, then that's the real battle you're fighting, not material selection.
Hey, Ken, you probably know I've done a bunch of wing nut testing on pressure-sensitive adhesive tapes. And I haven't done as much on Siga tapes as I have others. There's no particular reason for that. I think it was just like I couldn't, at the time, get a hold of Siga the way I could some of the others. But, one of the big deals is that when we bury sticky stuff inside assemblies, we really need to know how it lasts over time. So I see in your list of properties that there's anti-aging adhesive chemistry.
Right.
Can you talk a little bit about that?
Yeah, so when we develop our adhesives, because that's also one of the things that Siga does. We have our own chemistry labs, we have our own chemists, we develop, research, test, and then manufacture everything that we produce. So we go through a lot of testing to make sure that.
Hey, not to interrupt you, but only because Jake isn't on this one, but I think a podcast where the three of us are live from the factory in Switzerland. Just put that in the back of your head.
I agree.
Ken,
I love going to the
chat
factory
with ATM. But I mean, I love chemistry. I would love to see it firsthand and get a tour. And I know, we'd have to drag Peter out of there kicking and screaming. But I didn't mean to interrupt you, but I did. I'm being bossy.
That's okay. The lab is awesome. I love visiting the lab. Those guys and gals over there are smart as hell, and they do a really great job at what they do. But yeah, I mean, Peter, we test. So we've been around since 1966. So we have two things that are cool. Is that we test our adhesives like an accelerated aging machine that just cycles temperature, humidity cycles, and all that stuff over the membranes and tapes, and we're able to extrapolate data on doing these 90-degree peel tests on how sticky they are after 1 year. So a week in the machine is a simulated year of aging. So we stopped testing around year 50, and at year 50, they're almost exactly as sticky as they are on year 1. But then that's great and all, but we have been able to look at buildings that have used even our first generation of tapes, and those tapes are still very well adhered. And the other thing that's cool is because there's no off-gassing of any chemicals in these tapes, they don't change their chemistry over time. So they don't cure. They stay kind of not fluid, but they stay fluid. They stay flexible. The adhesive can still kind of move around a little bit. So that means that over time, as the building's moving around, we're not worried about embrittlement of the adhesive layer and the carrier layer. It'll stay able to move with the building throughout its life cycle.
Yeah, I mean, it's funny. When we first picked the name Unbuild It podcast, I was like, Unbuild It? I mean, seriously? But what's interesting is a lot of what I look forward to in learning more about field performance of building materials, I can't wait that we start actually unbuilding some buildings, right? Because, it's great to get laboratory results, but Steve and I both really feel the most comfortable when we can actually get in and take apart an assembly and see how the stuff that we worked with really worked over time.
Right. Absolutely.
Hey, the other thing I wanted to tell you is I don't know if I met you at a NESI conference, but I distinctly remember, and this might have been actually before you were with Siga, but I did a presentation with my buddy Dave Gothier at Nessie on our wingnut testing of tapes.
Yep.
And during that session, I said, well, it's unfortunate, but nobody makes a tape that sticks without a primer to concrete. And the guy from Siga walked up to me at the end of the presentation. He had fashioned the Fen trim, I think it was the IS-20, to carry a concrete block with a Fen trim handle. And he walks up and he plonks down the concrete block and he goes, I have a bone to pick with you. I'm carrying this block around without a primer. So to me, that's remarkable because, my understanding is that you need to prime masonry just because there's so much surface area and the material is so absorptive that you need to actually add adhesive to the surface of the material before you then add the tape. So is that mainly that the Fen trim is, got a shit ton of adhesive, built into it, or is it the type of adhesive as well?
It's a little bit of both. So the type of adhesive lends itself to better adhesion to masonry and masonry surfaces, and the amount too, because when you roll it in and you wet the tape, it really soaks into those pores of the concrete, and it sticks like a son of a gun.
Yeah.
It's really, really well stuck to what you put it on.
Well, and in fact, I didn't believe him, so I got him to give me some of the tape, and then I went home and tested it on my own concrete block, and I thought, damn, it really does stick.
Yeah, that was it was kind of funny because on my way back from Vermont, I realized that I hadn't listened to the last podcast, which was the pressure sensitive adhesive podcast.
Yeah.
So I was listening to that yesterday on my way back from Vermont from a project up there, and as soon as you said that, I'm like, that was my block. But I don't know if it was me. I think it might have been my boss because he was at the thing, and because I remember him coming back and being like, "I need this," and took it.
Yeah.
And
no, it was really cool because, you learn something new every day, right? I mean,
yeah, absolutely. No, it's so the kind of funny thing is that MyVest 500 SA, Steve. We just did a 6-story multifamily affordable passive house in Cambridge. And one of the reasons that we won that project was that the 500 SA's adhesive would also stick to masonry without primer. Right. So they went over the CMU block elevator shafts with the 500 SA. And I had the opportunity to go out there just before they closed in those elevator shafts. So it'd been 6-7 months. And it was really, really stuck really well.
Wow. So it's not just the tape, the Fen trim tape. It's the MyVest 500 self-adhered membrane that you can also do without a primer.
Right. Yep.
Wow. I didn't know that. That's pretty remarkable. Because I can imagine getting enough adhesive on a tape, but to get enough adhesive on a sheet membrane, that's a different story.
Right. And that's a big thing because, the more glue we put on it, the less permeable it gets. And we need to keep it above 10 perms for an exterior membrane on most builds.
Right. Yeah. Yeah. I think, I didn't realize this, but I was surprised that the code actually requires that weather-resistant barriers be vapor open, so 10 perms or more. I think that's actually, and I didn't realize that was built into the code, but I'm pretty sure it is.
Yeah. I think the commercial code's getting a little different because I see a lot of the commercial buildings, especially in the Boston area, going up with vapor impermeable, but there's no insulation in the stud cavity. So, basically the vapor barrier gets to the outside of the wall, and then the insulation so just moves to the other side of the stud cavity. But
interesting.
Hey Ken, your window tape. Correct me if I'm wrong, but I remember you can adhere it, and then you have a certain amount of time that is kind of adjustment time.
Yeah.
And then you come back tomorrow, and there is no more adjustment time.
Right. I would say so. It's adjustment time and also pressure. So if you just kind of tack it on nice and lightly, that gives you some ability to move it around if you made a little boo-boo. So tack it on nice and lightly. But once you roll it, you maybe got 10, 15 minutes. Even after initial rolling, it's nearly impossible to get off. But after 24 hours, we don't say cure because the adhesive doesn't dry and become hard.
Right.
We say it reaches just like maximum adhesive strength after 24 hours.
Yeah, that's always interested me, because if it's the pressure that wets the adhesive or, liquefies the adhesive so that it can go into the irregularities of the substrate, why 20, because they say, in 15 minutes, you're going to get 95% of the full holding power. But it's always like, well, we're no longer applying pressure. Why would it take 24 hours to get to 100%? I've never had anybody explain that to me, but it must be.
Hence the need to go to Switzerland, Peter.
Yeah, because I can't explain it to you either. I'm gonna have to take you guys over there so you can get it from the lab.
Yeah, but no pressure, Ken. No pressure.
Right, no pressure at all.
Oh no, there's pressure.
Yeah, you have to put pressure on ATN.
There you go. ATN's easy. Well, hey guys, we're closing in on an hour.
Yeah,
I think my brain training this morning is pretty much reached its limit. And but I will say this, only because he isn't here, and I have to take full advantage of this. But Peter, wasn't this very enjoyable? Like not having Jake.
You're not going to get me to do that, Steve. You're just not going to get me to do that.
Jake knows I love him. I'm like,
you can get yourself in trouble. Don't get me in trouble.
That's all right. Listen, I was born in trouble.
Yeah.
So that's okay.
Hey, Ken, really great to meet you on
likewise.
on the Electron stream. And look forward to doing some wingnut testing on some Siga tapes, man.
Yeah, you need material. I got material I can make sure you have.
Yeah.
Sounds good.
Ken, you want to plug where we can find you, man?
Yeah, so you'll be able to find me on Instagram. That's probably my first most active platform outside of like email and phone. My Instagram name is Tape Ninja Ken. So it's tape_ninja_Ken. I'm also on LinkedIn, cool. Kenneth Kiefer. That's pretty basic. Can be if you go to www.siga.swiss and look for me on there, you'll get my phone number and email and all that good stuff. Or if you're in New England and you want to come up to our training center is in Salem, New Hampshire. It's right near Canopy Lake Park, so it's easy on and off the expressway on 93. If you go to www.siga.swiss, you'll be able to get put on a wait list for when we reopen the training center, once we kind of figure out all the ramifications and requirements of the pandemic and find our way around, navigate that whole situation. But that's where I want to see most people, is at that training center.
Yeah, and I'll say, you can go out on the build show. I already did some videos where, we did the My Vest on that one project where we put it over the Advantech sheathing. But I also look forward to, come up there and check out your training center and maybe get a video or two there. But also, Jake and I are really excited about this project. And so we'll be talking about how we use My Rex in that project, and I'm sure we'll get a whole bunch of information out there to help y'all.
Yeah, absolutely.
Better understanding of what we did. So
beautiful.
So if you guys are good,
very cool.
I am good. I'm going to be bossy and say, shut up. You guys are done, and we're going to close this one out. So hopefully everybody. You enjoyed it. I'm Steve Basic, along with my good friend Peter Yost, and our special guest today, Ken Kiefer. You guys have an enjoyable day, building better out there, and long live our buildings.
Absolutely.
Until next time.
Right on, guys.
Get it right, build it tight.
There you go. Bye now.
Take care, you guys.
If you would like to get a hold of us, if you would like to ask a question, you can email the three of us, questions@unbuilditpodcast.com, or direct message us through our Instagram account. And if you contact us through either one of those avenues, and you also provide us with your address and you say, I would like one of those cool Unbuild It podcast stickers, we will mail you a handful of stickers. we're trying to spread the word about this podcast, and our idea here is podcasts aren't spread through paid advertising campaigns. They are spread through word of mouth because people care about the content. And so we want you to share a sticker, share the podcast with a friend, share it on Instagram, help us spread the word, and continue to grow the podcast. So until next time, questions, Midwest Symposium on Building Science, and stickers if you want them. Thanks for listening.